at another example. It says that if there are 7 boys, 3 girls in a gathering, so we are going to find the arrangements. He says that in how many ways they can be arranged in a row. So first arrangement is done in such a way that 3 girls form a single block. It means that there is no boy between any 2 girls. 3 girls form a single block. So the second arrangement is given in this way, such that end positions are occupied by boys and no girls are adjacent. So first we will find the number of ways for the first kind of arrangement. So look at this again. It says that 3 girls form a single block. We want to find the total number of arrangements. So we are given that there are total 7 boys and 3 girls form a single block. Since 3 girls form a single block, it means we can consider them a single entity, a single block, a single entity, right? So we can consider them a single entity. Okay, how many boys are there? Since there are total 7 boys, are 7 boys in total. So in the first part, this question has 2 parts. In the first part, we will find the number of ways of arranging 8 guys. Why 8 guys? Because we have 7 boys and a single block, right? We have 7 boys and a single block. So total arrangements for 7 boys and a single block of 3 girls of 3 girls is, so we have total 8 guys, 1 block and 7 boys. So that means we can use the formula for 8 guys and arrangements are also 8. We have 8 total guys and we have total 8 positions. Okay, what is the formula for this 8p8? It is 8 factorial over 8 minus 8 factorial, which is 8 factorial over 0 factorial. Since 0 factorial is 1, so our answer is 8 factorial. So these are not total arrangements. Because in this arrangement we considered 3 girls a single block. So that single block is this. You can see this is the single block. Here we maybe G1. Here you have to arrange G2. Here you have to arrange G3. But so to arrange girls 1, 2 and 3 in these 3 different positions, you have how many total number of ways? You have 3 girls and 3 positions. So the total number of arrangements are 3p3. So for the single block of girls, total number of now I'm talking about only the arrangements of girls. Total number of arrangements are 3p3, which is 3 factorial over 3 minus 3 factorial, which is 3 factorial over 0 factorial, which is 3 factorial. So in the first part, we have arranged 7 boys and a block. And in the second part, we have arranged only girls. So how many total number of arrangements are? Definitely the product of these two, because our event was divided into sub events. In the first event, we have considered a single block of girls and 7 boys. And in the second part of that event, we have found the total number of arrangements of girls. So total number of arrangements are total arrangements are 8 factorial times 3 factorial. Calculate them on the calculator. You will get the total final answer. So I'm going to solve the second part. In the second part, it says that end positions are occupied by boys and no girls are adjacent. Okay, first make end positions. You have total 7 number of boys, right? First, we have to arrange boys. Here you have B1. Here you should have B2. Here you should have B3. Here you should have B4. Here B5. Here B6. And here you have B7. You have total 7 boys. These are end positions which are occupied by, these are end positions. How many girls are there? There are total 3 girls. So since it is given that no 2 girls are adjacent, so positions, vacant positions for girls are this one, this one, this one, this one, this one, this one. How many positions are there for girls? There are 6. Definitely there are 6. Okay. First, we will arrange 7 boys in these positions 1, 2, 3, 4, 5, 6, 7. So for boys, we have 7 positions. There are total number of boys which are 7. Then we will arrange girls between them. So first, we arrange boys. Since there are 7 boys, so the arrangements for boys are the arrangements for boys are 7p7, right? Which is 7 factorial over 7 minus 7, which is 0 factorial. So its answer is 7 factorial. So this is the arrangement for boys. Now we have to arrange girls. For the girls, we have 6 vacant positions between boys. For girls, we have 6 vacant positions. But how many girls are there? There are only 3 of them. But there are only 3 girls to be arranged. So total positions are 6 and total girls are 3. So the total number of arrangements for girls are number of arrangements for girls are 6p3. Okay, what is the answer of this? It is 6 factorial over 6 minus 3 factorial, which is 6 factorial over 3 factorial, which is 6 times 5 times 4 times 3 factorial over 3 factorial. 3 factorial will be cancelled out. Its answer is 6 times 5 times 4. Okay. You have again divided this event. In the first part, you have arranged boys. In the second part, you have arranged girls. So how many total number of ways are there? The product of these two. So total number of arrangements are arrangements of boys and arrangements of girls. The product. Arrangements of boys are 7 factorial and arrangements of girls are 6 times 5 times 4. So this is your answer.